Guys, if you can't solve by factoring, then we're in huge trouble at this point. I told you that you can't be in the class if you can't factor, and I wasn't kidding. So today, what you just did is the teeny tiniest piece of the entire big picture here of one problem. So hopefully you were able to do it. If not, you better watch and figure it out. Okay, so it says find the solutions. If you weren't able to automatically say, I know I can solve by factoring if it's factorable, and if it's not factorable and solve by quadratic formula, you're in trouble. You better start going back and watching some old videos. So we would say to ourselves, it's quadratic, degree 2. So I look to see if there's a greatest common factor. There's not. We have all terms. So finding the solutions means I'm going to try solving by factoring. What multiplies to be 8 times c and adds up to be b, we've got to see if it factors. So what multiplies to be 1 times 3 and adds up to be negative 4. Most of you were able to say negative 1 times negative 3 equals positive 3, and negative 1 plus negative 3 equals negative 4. We could quick factor this because our a value was positive 1. So this factor to be 2 binomials being multiplied, x minus 1 times x minus 3 equals 0. And then if we set each of those equal to 0 and solve, we're going to add 1. So we get x is equal to positive 1 as a solution. We add 3, x is equal to 3 as a solution. That shouldn't have been too fast for you at this point in the year. Are we all comfortable with that? Everybody understands? Okay, sweet. All right, so today what we're doing is 2-3. We're going to be dealing with higher than degree 2 polynomials. We're going to be dealing with polynomials, linear factors, and zeros. So everybody make sure you're asking questions today. We've got to kind of go fast through this lesson. So pay attention. Do not let yourself zone out. Okay. So recall with quadratics, we like when we can factor the quadratic because then it makes it super easy to find the zeros, right? When we factor it, what we're going to do if we're solving is we're going to set the factors, the linear, degree 1. Do you see how these are linear factors, degree 1, degree 1? If a quadratic is factorable, we love it because then it's easy to solve. We find the zeros by setting each of those factors equal to 0 and solving. So right here, you would see that we get x is equal to negative 1 and x is equal to 2. And that's where it crosses the x-axis. Correct, everybody? That's what solutions are. That's what zeros are, is where it's crossing the x-axis. And once again, we factor a quadratic down to its linear factors. These are degree 1. All right, so when a polynomial can be factored completely, it makes it easy to find the solutions, like I just said. That's true for all polynomials. It doesn't matter if it's quadratic or cubic or 4th degree. If we can factor it down to its linear factors, degree 1 factors, then we can easily find the zeros, easily find the solution. So that's always our hope when we're given a polynomial is, does it factor? Does it factor completely down? So does everybody see that if I factored a cubic, why is it cubic? Because see how there's 3 x's here, everybody. Okay, do you see how if I factored some cubic down and got this, we'd be in good shape? Because then now they're all linear factors. It's easy at this point. We can just set each equal to 0 and solve for x. Does everybody see why we would want to get it factored? Now we're going to have 3 solutions. So when solving a polynomial of any degree, we first see if there's a greatest common factor that we can factor out. So for example, x cubed plus x squared plus x equals 0. If I said solve to you, you would say to yourself, this is cubic, not quadratic. So I would not be doing what multiplies to be 8 times c and adds up to be b right here. This isn't quadratic right now. It's cubic. However, isn't there a GCF in common? An x, correct? So we're going to factor out an x. Then you divide each term by x. So this divided by x is x squared, correct? This divided by x is x. So we'll have plus x. X over x is 1. Now look at it. We have a linear factor and a degree 2 factor. Don't we know how to solve degree 1s easily, right? Set it equal to 0. Don't we know how to solve quadratics? Yeah, by factoring. If not, quadratic formula. So do you see how this is going to work a little bit today? Okay, so we want to factor something down to where we have either linear or quadratic factors because we know how to solve those easily. And guess what? That's going to be the theme of this whole unit. We're going to have all these different kinds of polynomials that we're solving, and our goal is always going to be to get it down to linear factors, degree 1, or quadratic factors, degree 2, because we can always solve those. Is everybody feeling good about that? Okay, sweet. All right, let's get to it then. Let's do number 1. It says, write each polynomial in factored form and then check by multiplication. Then because we've got to get through 2 lessons with 1 stone today, I'm also saying not only factor it, but solve it. But that's easy. If you can factor it, solving it's the last step that's easy. Here we go. So number 1, first thing we're going to do is write each polynomial in factored form. And if I say to you, and on the test, all I'm going to say to you is solve. So you're going to have to look at the polynomial and say, okay, my first goal always with any polynomial is to see if there's a greatest common factor. So looking at number 1, what's my greatest common factor? Very good. So you're going to write 2x. Now go back and divide each term by 2x. So then we have 2x cubed divided by 2x, which is the 2's divide out. X cubed divided by x is x squared, correct? 10 divided by 2 is positive 5. X squared divided by x is x. Sweet. And then 12 divided by 2 is positive 6. And then x over x is 1. So we factored it. We've just factored out the greatest common factor. I'm telling you that I want you to solve it. So you're going to see if it continues to factor. Look, we have a linear factor and quadratic polynomial. So now we're going to see if this quadratic factors even more. Ignore 2x for a minute. Let's just focus on the quadratic. We're looking for what multiplies to be a times c, 1 times 6, and adds up to be 5. Careful though, a lot of people even on my honors test missed one like this. 1 times 6 is 6, 2 times 3 is 6. Okay, 1 and 6 could add up to be 5, but wouldn't this have to be negative? Is negative 1 times positive 6 positive 6? No, it would be negative 6. Therefore, we cannot use those factors. Does everybody understand why? There wouldn't be able to be a check mark over here because that would be negative 6. Positive 2 and positive 3, those are our factors, correct? So now we can quick factor it because our a value is 1. So this piece is going to factor to be x plus 2, correct? And then x plus 3. So now we can't forget that we still had a 2x. So we have factored it completely. Notice all of my factors are degree 1, degree 1, degree 1, degree 1. We've factored this down to its linear factors. Now we can easily solve. So we're going to set each factor equal to 0. Guys, I still have so many of you saying, what do I do with that? That's a factor, guys. That is a factor right there. That's a linear factor. You set all linear factors equal to 0. So you'll set 2x equal to 0. You'll set x plus 2 equal to 0. You'll set x plus 3 equal to 0. And now it's just algebra to get x alone. 2 times x. What do we need to do to get x alone? Divide by 2. 0 divided by 2 is 0. So we get x equals 0 is a solution. Guys, 0, the solution 0 shouldn't throw you off. 0 is just a number like any other number in the world. All right, then we'll subtract 2, correct? So we get x is equal to negative 2. We have our second solution, and we're going to subtract 3. So we get x is equal to negative 3. Is everybody feeling good? Now I want you to look and notice something. I have 1, 2, 3 solutions. Is it the highest degree on my polynomial degree 3? So if it's degree 3 on the highest polynomial, you better have 3 solutions. If not, you forgot a solution somewhere. Is everybody feeling good? Okay. Everybody understand it? Now what it means by check by multiplication is if we multiplied this back together, which is what we spent the entire time on last time, we would end up back up here. Because, right, we know that factoring is the opposite of multiplication, right? So we could check this one by multiplying it back in, right? And remember, my suggestion to you was multiply 2 of them together first and then multiply in the third one. I'm not going to take time to do that. But you could check it by multiplication. Okay, let's do number 3. It says write each polynomial in factored form and then check by multiplication. I'm telling you to also find the zeros. So with polynomials that are not degree 2, even with degree 2, we say to ourselves, okay, is there a greatest common factor? So in number 3, isn't there something in common? I like that you say negative 3x. If we have a negative in front, it's probably best to factor out a negative. So we're factoring out negative 3x. Does everybody understand why it's negative? Only if there's a negative in front. Now you've got to be careful and divide each term by negative 3x. You've got to pay attention to little details in secondary 3 just because there's so much to each problem. You mess up in one teeny place, your whole problem's wrong. So negative 3 divided by negative 3 is 1. X cubed over x is x squared, correct? Positive 18 divided by negative 3 is? Good, negative 6. X squared over x is x. Negative 27 divided by negative 3 is positive 9, correct? And then x over x is 1. Okay, look. We factored it down to a linear factor and a quadratic. So now we'll see if our quadratic continues to factor. So 1 multiplies to be a times c, 1 multiplies to be 9, and adds up to be b, which is negative 6. 3 times 3, you're right. We should be getting better at just seeing these right off. 3 times 3, they both need to be negative, correct? Check it here, it works, and check it here, it works. So we can quick factor it only if our a value is 1, and it is. So now we're going to factor that down. We know it's going to factor to be x minus 3 times x minus 3, correct? And now we can't forget this negative 3x originally that we factored out. Now look, we have degree 1, degree 1, degree 1. We have 3 linear factors. Sweet, now it's easy to solve. Set each of those equal to 0 and solve. So right here, to get x alone, we'll divide by negative 3, divide by negative 3. 0 divided by negative 3, 0. There's one of our solutions. We'll add 3 to both sides of the equation, giving us x equals positive 3. Add 3. So x is equal to 3. Now in secondary math 3, it is no longer appropriate from this point on to say x equals 3, x equals 3. This is how you need to write it. So we have x equals 0 as a solution. And then we get x is equal to 3. And since it happens twice, that's called having a multiplicity of 2, meaning it happened multiple times. 3 happens twice, correct? So it had a multiplicity of 2. It happened multiple times. It happened twice. So we would say x equals 3 with a multiplicity of 2 because it happened twice. So if we got another x equals 3, we would have said with a multiplicity of 3. If we got it 4 times, if we got that solution 4 times, we'd say with a multiplicity of 4. So here's our final answer. Everybody feeling good about these problems? Are we good? Okay. So just look up here. I don't want you to write anything. I just want you to look. It says, factor the polynomial completely and find the zeros. So we have x cubed plus 4x squared minus 4x minus 16. Okay, is there a greatest common factor in this one? No, right? There's no x. 16 doesn't have an x. Can anyone remember how we factor these ones? Yeah, grouping. Don't we have 1, 2, 3, 4 terms? So you say to yourself, I'm going to factor by grouping. So you group the first 2 terms, you group the second 2 terms, always grouping the sign. The greatest thing in common here is x squared, correct? So you're going to pay attention because this one's going to come out a little differently. So we'll divide by x squared, divide by x squared. So left is x plus 4, correct? What's in common here? We'll pull out negative 4, divide by negative 4, divide by negative 4. So that's positive x and then positive 4, correct? It does factor by grouping because our safe haven's the same. Does everybody understand? So we'll factor out x plus 4, and left was x squared minus 4. Now we factored it. We have a linear factor, degree 2 factor. So shouldn't we see if the quadratic factors even further? So we do. What multiplies to be a times c? What multiplies to be a times c? What multiplies to be negative 4? Does everybody understand why a times c is negative 4? And our b value is 0, correct? There's no middle term. Does everybody see it? So it multiplies to be negative 4 and adds up to be 0. Those ones are really easy. Well, negative 2 times positive 2, correct? Negative 2 plus 2. So can we quick factor it? Yes, our a value is 1. So this piece factors to be x minus 2 times x plus 2. And then we still have this x plus 4. Now look, haven't we factored it down to linear factors? Now we'll set it equal to 0 and solve. So we get x is equal to, let's do it in our heads, we would have set it equal to 0, subtracted 4. Negative 4, we get x is equal to positive 2, and x is equal to negative 2. Look, we have 3 solutions. You better have 3, because see how it was degree 3? Yes. Then there should be 4 solutions. Okay, any questions? Do we need another one factoring by grouping?
We will do number 2.
I want you to do number 2, but we'll get there. Okay, let's do this one for a reason. There's a reason I'm doing this one too. So everybody look up here. It says factor the polynomial completely, then find the zeros. So it's 4 terms, correct? No greatest common factor. So once again, factoring by grouping. Watch, this one's different. I did it on purpose. We pull out x squared, correct? Left is x plus 8. We pull out a positive 8, correct? And then left is x plus 8. It did factor by grouping because we have a safe haven. We'll pull out x plus 8. Left is x squared plus 8. Now let's see. We have a linear factor degree 2. Let's see if the quadratic factors. Now notice, we're going to see if it factors. Well, multiplies to be 8 and adds up to be 0. Is there anything? No, right? So it didn't factor. Okay, so we factored it completely, but now I'm telling you to still solve it. So let's solve each of these. So we know how to set each of those equal to 0 and solve. So we have x plus 8 equals 0. And this didn't factor, but we still know how to solve quadratics if they don't factor. So let's solve this one. Want to just be negative 8, guys? X equals negative 8. There's one of our solutions. Now, how do we solve this quadratic that doesn't factor? The easy way. Would I do quadratic formula? Heck to the no. There's a much easier way. What would we do? It's missing the middle value. So wouldn't we? What? It didn't factor, right? We tried factoring. That is our first step to try, though. So wouldn't we isolate x squared? Square root it. Subtract 8, guys. Subtract 8. So we have x squared is equal to negative 8. Now what will I do? Square root both sides of the equation. Root cancels out with power. So we have x is equal to the square root of negative 8. Is that answer simplified? Not even close. We got to keep simplifying it. See why we spent so much time making sure we could solve a quadratic appropriately? If you couldn't do that, you would get the entire problem wrong, even if you could do the hard stuff. So we simplify this down. We know this is the square root of negative 1 times 8. 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. Aren't we pulling our groups of 2? Because it's square root. So we pull out a 2, correct? Don't we pull out an I for the negative 1? So this simplified to be 2i, and then left underneath the root was 2. So x is equal to, what did I forget and almost forget? Can anyone remember? Plus and minus, correct? So we pull out a 2, we pulled out an I, and left under the root was the square root of 2. So there's our other 2 solutions. 1, 2, 3 solutions, it was degree 3. Everybody feeling good? So if you can't solve the quadratic by factoring, then solve it by a different method. Does everybody understand? Okay. Awesome. So, I just want to say one more thing. Do you guys all understand that if we were to graph this, it would cross the x-axis at 0, 3, and negative 3? Oh, no, it just crossed at 3. Okay, perfect. And then it crossed at negative 4, 2, and negative 2. We graphed it. That's where it would cross the x-axis. Right here, it would cross the x-axis at negative 8, but these imaginary solutions would never cross the x-axis, right? Those are like a floating solution. Okay, so I want you to do problems 1 through 5, cross out number 6 completely, and then fix problem number 5 to be what I'm going to put on the board. So that's what number 5 should be. So solve. Ready, set, go. Okay, so recall back to when we've only briefly talked about this, because I couldn't go back into secondary 2 too deep because we just didn't have time. But we did talk about this. When we have a quadratic that has solutions where you get the solution twice, such as x equals 3 and x equals 3, if we were to graph that, that's when a quadratic bounces, correct? Everybody? It touches down, technically stays there for a second, bounces back up. That's when we get the multiplicity of 2. So, for example, x minus 3 squared, if I said you solve, you'd say, okay, I know that x minus 3 squared means x minus 3 times x minus 3, correct? So then we would set each of those equal to 0 and solve. So we get x equals 3 and x equals 3. So we got it twice. So if we were going to graph that, that's when it's going to bounce at 3 and go back up. Does everybody understand? Yeah. So if I said solve this one, x plus, let's say this was negative in front. So we would rewrite this as, negative, because I put it upside down. Anyways, so we would set each of those equal to 0 and solve. We get x is equal to negative 6 and x is equal to negative 6, correct? Now, because there's a negative in front, that's what flips our quadratic upside down, right? So it would look like this, come up, touch at negative 6, and go back down. Do you see how it still bounces? Everybody feeling good about that? So these roots are with multiple multiplicities. So even multiplicities will bounce on the x-axis. So do you know how degree 2 was even? That's when it bounces. Now, so look right here. Y equals x minus 8 squared. We know that's x minus 8 times x minus 8. So what do we say? X equals 8 with a multiplicity of 2. Everybody? So isn't 2 even? 2 is even, correct? So it's going to bounce. So we're going to go to 8, and this is a quadratic, and so it's going to bounce at 8. All right, now look right here. We have x minus 8 to the 4th. So really, isn't that x minus 8 times x minus 8 times x minus 8 times x minus 8, right? So we get x is equal to 8 with a multiplicity of 4, right? Okay. If you were to graph that, graph it in your graphing calculator, type in, go to y equals, I want everybody to see it. Go to y equals, type in x minus 8 to the 4th. Okay. So everybody, go to y equals, type in parentheses x minus 8, close your parentheses, raised to the 4th, hit graph. Now you got to make sure your window, my window's bad, I can't even see it because I can only see down as 1, 2, 3, 4, 5. So I'm going to go to window, x max. I'm going to change it to like 10 because then I can see the 4th degree polynomial. Ah, I changed the wrong thing. No, I didn't. It's just taking a minute. Oh, I might have changed the wrong thing. What did I do? Oh, that's y max. X max, I'm going to change to 10 just so I can see as far over. Now look, it kind of looks like quadratic, but it's not. Degree 4 is a little bit, I mean, all degree 4s can look different, but we do know, but do you see how it kind of looks like a quadratic? Okay, so it is bouncing at 8 still. But do you see how an even degree is still bouncing at 8? Everybody? Yes or no? Okay, so it kind of looks a little bit more like that, but it's bouncing at 8 still. So degree 4. It had a multiplicity of 4, so it bounces. Now on multiplicities, we can still have multiple multiplicities with odds, but they will actually still just cross through the x-axis and not bounce. Did you all hear that? Odd multiplicities will not bounce. They will cross through still. So right here, x plus 2 cubed. Don't we know that that's x plus 2 times x plus 2 times x plus 2? Everybody? So don't we get x is equal to negative 2 with a multiplicity of 3? Because 3 is odd, it's just still going to cross through at negative 2. So it's still going to just cross through at negative 2, even though it had multiple multiplicities. If you don't believe me, graph it. However, it still happened 3 times. Does everybody understand what I'm saying? Okay, so same thing here. We would get x is equal to negative 3 with a multiplicity of 5. And if you graph that, it would still cross through at negative 3. But it happened 5 times technically. Okay. It's just because it's odd. Odd functions, they all have, I mean, end behaviors are matching up. You know, all odd functions can look differently, but what I'm saying is it's going to cross through negative 3, not bounce, because it's odd. Okay, so find the zeros. So right here, look up here. It says find the zeros. Right now, don't we need to factor it to find the zeros? So just look. I want you just to watch and learn. Observe it, take it all in. So it says find the zeros. So I would say, okay, to find the zeros, I'm going to factor it. So when we factor out x and get x squared plus 2x plus 1. Everybody, we've got to be able to go quick. Does everybody understand why? Okay, so we would continue to factor it. So we would factor out the quadratic, what multiplies to be 1 and adds up to be 2. That would be 1 and 1. So this is going to factor to be x plus 1 times x plus 1. So I factored this all the way down. So don't we get x is equal to 0? X is equal to negative 1 with a multiplicity of 2. Okay, so I'm going to graph this now. So this is what we do when we graph. The first thing you do is plot your zeros. So we're crossing the x-axis at 0. We're crossing at negative 1. Okay, does everybody follow? Okay, now we know our end behavior is odd, or we would look right here if it was factored. X times x times x. Isn't that x cubed? We only need the leading term for end behavior, correct? So now I'm going to draw in my end behavior. We know it is opposite end behavior. It's positive, so down and up. Everybody? Right? So I'm drawing down and up end behavior here for my 2 zeros, my ending 2 zeros. Now I need to know what happens in between here. So does it come down? Does it what? So I want you to notice. Didn't we have a multiplicity of 2? So that's where it bounces. So it's going to touch down at -1, bounce down, and then come back up. See how it bounced at -1, everybody? Okay. Slide through my graph. Doesn't have to be perfect. Well, we could, and we could also, this is actually what I want us to do. Let's plot a point between the 2 zeros. The thing is, I don't want to get too detailed today because we don't really have enough time. So I'm just drawing a rough sketch. So I'm going to just stick with that for now. Does everybody understand how it bounced at -1, touched at -1, bounced down, and then it has to come back up and cross through the only other 0? Okay, I'm not going to get too gory of details because otherwise we're going to be graphing all day long. Is everybody okay with just drawing a rough sketch? Okay. Yep, because it was even, it had to bounce. Yep, and we knew it was coming up through the bottom because it was down and up. Does that make sense? Okay, let's do number 9. It says find the zeros and graph. So notice this one's already factored for us down to linear factors. That's awesome. So we already have it factored. So now we're going to find the zeros. Set each of those equal to 0 and solve. So don't we get x is equal to 0, x is equal to 2, and x is equal to -5. Okay, now we're going to graph that. So you go to your x. Do you guys even have oh yeah, just draw yourself a rough sketch. Draw an xy plane, everybody. And then do some tick marks up to like 10, -10, +10, -10. I'll give you a quick second to do that. So whenever graphing, our first thing is to plot the zeros. So it's crossing at 0, crossing the x-axis at 0, it's crossing at 2, and it's crossing at -5. I'm going to let everybody get caught up. The second step is to say to yourself, what is the end behavior? So let's look at this. We only need the leading term for end behavior. So I'm going to do x times x times x. Won't that be x cubed? Positive x cubed, right? There's no negatives in front of the x's. So won't this be a positive opposite end behavior? Like this? So it's down and up. So go to your zeros. The end 0, we know it's going to be coming down out of that 0, down, and then it's going up through the other 0. Now we need to know what's happening in between here. So we could just plot points. Type that into your calculator. Everybody pull up your calculator. Go to y equals. Type in x times x minus 2 times x plus 5. You can literally just type that in. So you have x parentheses times x minus 2, wasn't it? And then x plus 5. So parentheses x plus 5. Now we could look at the graph, or we could look at the table of values. I'm just going to look at the table of values real quick and plot some more points. Does everybody understand how we can always plot points? So I'm going to hit graph or second table. I want to look at the table of values. So you guys pull up your table of values. What is there a whole number point? Like what's -4? You're just looking at -4. What is -4? Okay, 24. I don't want to plot that one. It's too high up. What's -3? 30? Don't want to plot that one. How about -2? 24. And then how about -1? -1 and 12. Okay, so we do know it's coming clear up here, correct? And then at -1, it's up at 12. So somewhere right here it's crossing. So then it has to come down and touch that 0. Going clear up there. My graph isn't very good because this isn't drawn to scale very good. And then, what is 1 at? Just curious. -6. Okay, so 1, -6. Ding, ding. We've drawn in this cubic. It's kind of hideous, but. Questions? We're all feeling good about this? Pretty much? Okay. So if I said to you, find the zeros of this one, we would get x is equal to 1, correct? X is equal to -2. And x is equal to -3 with a multiplicity of 2. Okay, so everybody just watch. Of 2. So I'm going to plot the zeros. That's always my first step. I plot it at 1, at -2, and at -3. I'm going to look at my end behavior. Careful here. A lot of people will miss the end behavior on this. X, and x squared. Won't that be x to the 4th? There was all positives in front, so it's positive x to the fourth. So it's even, so it's same end behavior, it's positive. So I want to be up and up. So I go to my zeros. From this 0, I'm going to go up. From this 0, I'm going up. Now I need to know what happens down here. So I'm just going to look at my zeros and see if there's another hint here. It says -3 has a multiplicity of 2. So it's going to bounce, right? At -3, guys. So it touched, it's got to bounce. So then it's going up somewhere. And then it's going to come down and cross through -2. And then it's crossing through -2, right? Not bouncing. So then it's going to come back down and then touch. Something like, we're just doing a rough sketch. If it has an even multiplicity, it bounces. Odd multiplicities will cross through. So I could have plotted this point in between to see how high up to go, but I'm okay with the rough sketch today. Does everybody understand? Okay. So do 1 through 12. First, find the 0. Second, graph the 0. Third, draw an end behavior, and then fill in the x values between your zeros. So just sketch in the best graph you can. Ready, set, go. Okay, so this part is always a little bit confusing when I teach it at first to regular. So make sure you guys really pay attention, because if you understand where I'm coming from with this and you understand where I'm getting this, then it's going to make it a lot easier. Okay, so it says when given the roots, so that means when given the solutions, when we solve it, we're finding the roots, right? So it says when given the roots, we can work backwards to find the polynomial that gave us those particular roots. So this time we're going to work backwards. They're saying these are the solutions. So normally are we given a polynomial, we factor it down and then set it equal to 0 and solve. This time we're going literally backwards. Exact steps but backwards. So think about it. If these are the solutions, then can't we work backwards and figure out the linear factors when they were set equal to 0, before they were solved? And then after that, we would say, okay, they used to be multiplied together. You'll multiply them back together. So what I do is say, okay, if these are the solutions, so I write out x equals -1, I write it out. You have to, x equals 3 and x equals 4. Those were our solutions. What? We've already been given the solutions, correct? Everybody? So I'm going to write them out individually like this for a reason. So if that was our solutions, then what was our linear factors? Before they were set equal to this, they were set equal to 0, correct? So let's get this side equal to 0. Algebraically, how do we get this equal to 0? Add 1, add 1. So over here, we have an x plus 1 equals 0. Does everybody understand that that must have been the linear factor if we got this as a solution? Yes or no? Okay, let's get x equal to 0 here. So we would subtract 3, subtract 3. So we had x minus 3 equals 0 before we had x equals 3. Same thing here, subtract 4. So we had x minus 4 equal to 0. That was the linear factor before we got the solution 4. Now before we split them apart, think about it, weren't they all multiplied back together? So it was x plus 1 times x minus 3 times x minus 4 equal to 0 before we could set each of them equal to 0. Does everybody see how we're just working backwards here? And now we want the polynomial in standard form, so we're going to have to multiply that out. So take my suggestion, anytime you're multiplying 3 things, multiply 2 of them together first, combine all like terms, and then multiply in this one. So x times x is x squared, x times -3 is -3x, 1 times x is positive 1x, positive 1 times -3 is -3. We would combine like terms. So we have x squared minus 2x minus 3, correct? Everybody. And then we have our x minus 4. So now we've got to distribute that through. So it's a good thing we practiced this last time on the last worksheet. So now we say, okay, we have this stuff times this stuff. I'm going to take x and multiply it in. So that's x cubed. That times that is minus 2x squared. Are we all following? And then x times -3 is -3x. And then I had Joe show me how he lines his up to make it a little bit easier. So I'm going to do that this time. -4 times x squared. Let's line it up with the x squareds. So -4x squared, correct? Everybody? -4 times -2x is positive 8x. Do you see how it's lining up? So we can add straight down a little bit easier. -4 times -3 is positive 12. Now we add straight down. It does make it easier. X cubed, no other x cubes. -2x squared minus 4x squared is minus 6x squared. 8 minus 3, positive 5x's, and then plus 12. So guys, this was the quadratic in standard form that gave us those solutions back up there. Wouldn't we, does everybody understand how to do it? Going backwards. Do we need another one, or do you feel good to go? You want me to do 16 with you? All right, let's do 16. So we're asked, given the solution, what's the polynomial? So we have x equals 4, we have x equals 2, we have x equals negative 3, and we get x equals 0. We're working backwards to get the polynomial. So let's figure out the linear factors. They used to be set equal to 0 before we had solutions. So minus 4. So we have x minus 4 equals 0. Subtract 2. So we had x minus 2 equals 0. Does everybody see what I'm doing? We'd add 3. So we had x plus 3 equals 0 before we had that solution, and x equals 0. Sweet. And now, before they were split apart and equal to 0, they used to be multiplied together and equal to 0. So that x is just an x. Everybody, do you all understand that? Now we're going to multiply them together. So multiply 2 together and multiply 2 together. And then we'll multiply all of it together. Here we go. X times x is x squared. X times negative 2 is minus 2x. Minus 4x right there. Negative 4 times negative 2 plus 8 combined like terms. So we get x squared minus 6x plus 8. Correct? So we have that. And then right here we have x times x, which is x squared. X times 3 is plus 3x. So now we have to multiply by x squared plus 3x. Everybody feeling good? Let's keep going. We've got to be able to multiply these out correctly. So x squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. X squared times positive 8 is positive 8x squared. Is everybody feeling good? Positive 3x times positive x squared is positive 3x cubed. I'm going to line it up like Joe showed me. Positive 3x cubed. 3x times negative 6x is negative 18x squared, correct? 3x times positive 8 is positive 24x's. Is that right? And now we'll add straight down. X to the 4th, no other x to the 4th. Negative 3x cubed plus 3x cubed is negative 3x cubed. So I added those down. Positive 8x squared minus 18x squared is minus 10x squared. And then plus 24x's. So we worked backwards. That was the polynomial that gave us those zeros. Clear back up there. Everybody feeling good? Ready to practice some? Okay, do 13 through 18. Everybody, we're going to speed through this because we already know how to do it. It's just continuing it. It says find the zeros. So don't we say, okay, we find the zeros, that's solving it, right? Isn't this one already factored? So we have x minus 8 times x minus 8. Solve for x. When we get x equals 0, x equals 8 with a multiplicity of 2. Okay, write it. Okay, then let's do another one. Hurry. Okay, 13 through 18. Guys, aren't all of those? Look at 13 through 18. Oh no, number 23. Here we go. It says, find the zeros. Doesn't that mean solve it? Yeah. Is this one factored? No. We've got to go through it just like we did on problems 1 through 6. What's the thing in common here? So we're factoring out 9x, divide by 9x, divide by 9x. So then left is x minus x squared minus 9. Now we have a linear factor, quadratic factor. We look for what multiplies to be negative 9 and adds up to be 0, right? Negative 3 times 3, can we quick factor it? Yes. So this factors to be 9x times x minus 3 times x plus 3, yeah? Now solve. You guys can solve that, right? We're good. Do you guys all understand when it says solve that you're just solving? Some of them are already factored for you. We're all good? Okay. So I guess we'll have to, I'm only going to make the whole front page do this time. Do not cross out the back page. We're going to have to learn some of the back page. But you guys, I'm telling you, you've got to go home and do the homework and figure out the front page because we're going to be learning a lot next time. We have a whole other lesson to get to. Just, we have to double time it when we spent so much time with other stuff. All right.